So we know of two methods. We know of two methods for solving equations so far, right? We started with the graphing method. Remember the graphing method? You graph the first equation, it's a line. You graph the second equation, it's a line. And where the two cross, where they meet, that's your solution. The problem with graphing, there's a couple, it takes forever. And some of those, like that problem we did today, number 1, the y value was 24. I don't have graph paper that big. So we learned another method last week called the substitution method. And remember, the substitution method, you had to have x equals or y equals something, right? And you plugged it in. You listening? So what happens? Neither one of these is x equals or y equals. So what are you going to do with that? You'd have to get x equals or y equals, right? And the way that you get it, you bring it to the other side. I would use this one right here because I've got a y. I've got a 1y. So that means I want to get rid of the 3x here. How do I get rid of that 3x? You subtract 3x. And so now this equation, the 3x drops out, you get y equals 4 minus 3x. Did you see that?
Yeah.
So y equals 4 minus 3x. And then what are you going to do with that? Well, now you're going to go to the other equation that you did not use yet. 5x minus y equals 12. And you're going to plug it in right there. Right? I'm not going to finish it because you know what to do from there. But the idea is you have to get 1x equals or 1y equals. But today, look at this. I had 1y right here, so that made it easy. Over here, I don't have a 1x or a 1y. And that doesn't mean I can't use substitution, but that means my job is going to be a little bit more difficult, right? So today I want to show you this. You know how to add. I'm going to show you the addition method. It's pretty easy. It's pretty easy, I think. I'll show you and then you can tell me if you think it's easier. The addition method, you have to have one thing. You know how the substitution method, you have to have x equals or y equals? Well, with the addition method, here's what you want to have. Are you watching?
Yeah.
You want to have opposites. Do you see right here I have a positive 2y and a negative 2y?
Yeah.
In order for the addition method to work, you have to have opposites. Positive 2y, negative 2y. Watch this. If you have opposites, you're going to draw a line and you're going to add those two equations together. What is 10x plus 6x? 16x. Look at this. What's negative 2y plus positive 2y? Nothing. Goes away. And what's 24 plus 8? Now you can solve that, right? 16x equals 32. Divide by 16, and you get x equals 2. Pretty easy, right?
Yeah.
And we're not done yet, though. You still got to get the y that goes with it. What is the y that goes with it? Well, How did you get the y for this one? How did you get the other variable? You had to put it back in, right? Well, here, you're gonna have to put it back into one of these two. It doesn't matter which one you choose, you'll get the same y value for both. I usually like to pick the one, this one has smaller numbers. I usually pick the one with smaller numbers. It doesn't matter. Here is the bottom equation, 6x plus 2y equals 8. 6x plus 2y equals 8. What is x? 2. So I'll plug that in here. And, ooh, that's not what I want. I don't want to plug in an x. What do I want to plug there? 2. Whoops, almost made a mistake. Did make a mistake. So I get 12 plus 2y equals 8. Now what? Yep, I got all the y's together. I need to get rid of what's with it. So what does that mean? 2y equals negative 4. What do I get for y? Does that make sense?
Yes.
It's not too bad, right? So in order for this to work, though, you have to have opposites. So look at this one. Do I have opposites? Not quite, right? I have 6c and 6c. I need one of those to be negative. So here's what I'm going to do. This one, I'm going to leave it alone. And it doesn't matter which one you choose. But that one I'm going to leave alone. And this one, if I don't have opposites, I'm going to multiply everything by -1. So what will I get there? Negative 6c. And what will I get here? -1 times -2. Positive 2d. And then don't forget to multiply the other side. -12. And so then, once I have, now I'm going to add them up. This is beautiful. Are you ready?
Yeah.
6c and a -6c drops out, right? No c's. 7d plus 2d, 9d. -15 plus -12. And I get d equals -3. Am I done?
No.
No, I still have to get what is c equal to. How am I going to do that? Pick any one of those equations you started with. Doesn't really matter. Should I pick the top one this time?
Yeah.
Plus 7d equals -15. 6c plus 7d equals -15. But what is my d value? -3. -3. So now let's work it out. 6c, is that -21? Got all the c's together. How am I going to finish it, Reese?
So you got all the c's together, right?
Right, add 21 to both sides. 6c equals 6. What do I get for c? 1. No. So there you go. Yes?
Isn't there already a positive and negative in the equation too? Like in the beginning of the equation. If you got c plus, 6c plus 17 equals -15.
-15.
And then you got negative.
But you have,
Numbers.
in order for it to work, those have to be opposite. If it's 6 and 6, these, if you just add them up the way they are, this is going to be 12C plus 5D equals -3. See, the problem is then something doesn't drop out. In order for this method to work, when you add them together, one of the letters has to drop out. See how the C's dropped out? And over here, the Y values dropped out. Sometimes this method is called the elimination method. Do you see why it's called the elimination method? What did we do to the Y? We eliminated it. What did we do to the C's over here? We eliminated it, right? Yes, Tom?
Okay, so when you got the D equals -3, if you're gonna put it back in, so like the bottom one, would it be -1?
It doesn't matter as long as you either use this whole thing or you use the one where you multiplied all of them. It doesn't matter which one you use as long as you're consistent and use either this whole thing or this whole thing before you multiply. But it'll work just as well if you plug it into that one. Does that make sense? Do you have any questions? Do you think it's easier? Do you think it's easier? It's not bad, right? So this is your assignment right here, but listen up. You know, now you have 3 methods. You have graphing, you have substitution, and you have this addition method. These last 2 problems, you're going to turn the page. It says for those, solve them with whatever method you want for 20 and 21. Please don't use graphing. Pick either substitution or the addition method. Yes?
Like substitution, can you do it for anything then? Just like
Well, like this one, substitution wouldn't be very good to use because you don't have one C or one D. So if you try to use substitution, you're going to get fractions in here and it's going to be a mess to work with.
Alright.
So that's why this method works easier. So anybody else with questions? Anybody else with questions? Anybody else with questions? Holler if you need my help. Yes. Yes, sir. 13.